John said, I'm Ben, this is Darren and Peter. We're obviously doing lots of computer and learning environment. These are the essential goal that we're really trying to create. I think mostly because it sort of fosters a subconscious understanding or tactile understanding of things. I think it's also important to sort of the level of engagement that it allows people to learn. Like when I was young, I didn't do so hot in school. My mom always used to tell me, oh, you just need more hands-on things, more interactive things. So I think just in general, if you're more involved with something, you can touch it, really get your hands dirty, you really get to another whole level of understanding. So that's really essentially what our project's about. And so we really want to solve sort of fundamental issues that we learned from our initial site visits, which we noticed was quality of construction. The storage aspect was universal, that every teacher wanted more storage. And then sort of adaptability or class-specific adaptability, so that your environment can transform to the needs. So you're not just getting a box that's the environment that you have to cater to, that the box actually caters to your needs. And so we started off with a panelized system, similar to you see up here, where there's just essentially a catalog of parts, and you can sort of programmatically pick your pieces where they're going to a wall system. And that fosters a lot of problems within our wall system. So we really kind of took it back to the structure itself and let that reinform module panel idea.
So it was this sort of adaptability that Ben's talking about, and so how do we achieve that through modular design, portable design? So we really took the idea of modular to the next level, and it really starts with this idea of the catalog parts on the top. But here, instead of creating these sort of pieces or masses that are attached to a wall, we created this frame system where the frame itself becomes a module. And this was the early sort of study of it. And this is sort of based on two things. One is the monocoque structural system of shipbuilding. How ships are built in this sort of cellular idea. And then also the beautiful scissor display pieces that we have that interlock together. So in doing so, we create these great voids that just become this playful thing that you do a million and one things to. So here is our structural system, and literally With the creation of these voids, what we've done is now is taken the classroom and created a dual wall. We've created the void space on not only the interior but the exterior. So this creates a sort of vibrance between the entire environment of the classes within interior and exterior, allowing the wall to become this sort of flexible thing that can programmatically pull and extract parts, equipment, furniture, pieces, interactive windows, etc. So with our initial diagrams talking about the classroom, we started with this sort of breaking down the traditional barrier of the classroom. Breaking it down into some different uses. These are really small diagrams. You have an open space, you have nodes, you have lab-style tables, computer lab style, open, more playful, round configuration. I'm sure we've been playing with that a little bit today. And then even breaking it down further into the classroom part and exterior. So, back to the model. What can this do for us? How is it doing? It goes back to the catalog, which is both a benefit but also sort of because it becomes so overwhelming. As we come up with ideas, it just becomes overwhelming. Like we can do this, we can do that, we can do this. Simple programmatic things at the same storage, cubbies, windows and mats. The floor can come up for storage, the ceiling and skylights, we can drop projectors, you name it. Everything sort of packs into the wall. But then, a part of this, we came up with one idea that we really took forward. We adaptable and fixed. And Ben's going to go into
But yeah, I guess our main take from this is that in terms of having the number of options that this module made, the adaptability was within the one module itself. So we took a sort of a block board, and that can become tables, chairs, pretty much anything you can use to program it. And I was thinking of ways to get these blocks to connect together in one system so you can expand stuff, you can cantilever stuff. I was working through mechanical fastener ideas, and then I went over, and this is a white Studios glass in this case, sort of Jacob's ladder theory, and it just spins around. So I kind of figured that out, how that would work, and applied it to the block system. Essentially, allows you to just flip it over. And so it does allow you to have the connection of the block in the normal spaces, but also you're able, because the extra face of the block, you're able to cantilever, you're able to span in. So we took that forward into sort of a series of blocks, all the different configurations that you could possibly want. So by putting these things on adjacent faces, you're able to create a series of different movements, so that you can create essentially pretty much an issue on something. And that's sort of manifested in our final model here. That these things flip over, become seating if you want. Obviously you saw your bench or talking about a bed later. I flip. There's sort of a limitation that's really intriguing in sort of the reaction that one move causes. One certain move sort of sets up this chain reaction.
something from the beginning of our design concepts that came up was these boards bring up so many ideas and so many opportunities for uses that we really, as a standard, set for ourselves this idea of multi-use for everything in space. So just as these blocks are shown, you can sit on them, they can be stacked to become higher, to use tables or demonstrations or tutorials or whatever. But really getting as much bang for your buck and being able to use every square inch of the space at least to creating sort of this learning environment that the kids kind of actually create. The teachers have a lot of influence, but the kids can kind of pull things down and create their own environment. They will, create an area for a small group. They can pull modular out and read on it and play on it and grab toys and other stuff. And this model starts showing some of the pieces that come out. So this gets translated also to the exterior. So our sort of next step was just the ground to set up a connection to the site. So one adaptation that we took was a sort of playing off two classrooms that are shifted in axes that create two outdoor classrooms, and then taking our same system of the monocoque and pretty much taking it and making a grid shell on it and creating a patio that also becomes interactive. Both with ideas for where you can have sandbox in the modules, planters, you can have trees come up through, kids can kind of interact, they can pull the mods outside, the end walls and glass. Collapses all to one side, so it becomes very transparent. It opens up to this patio space. Kids can go out there, do their own experiments, play. We worked a lot with the environmental layout that they go down the creek, pick insects, pick bark off the trees, come back, analyze it. And then we also looked at some of the potential ideas that this module could do for us. Besides stacking, we have different end conditions.